you have set the diagnostics on your calculator, the correlation coefficient is right here for you. It's that R value. Now, what does it say to round to? To the nearest thousandth. So if we take this R and round it to the nearest thousandth, 3 decimal places, it's going to be 0.915. So R, we'll write that right here, equals 0.915. So that's a really high correlation. That's really close to +1. So it means that, if the students scored better on test X, they probably did better on test Y as well. And again, just want to reemphasize, a positive correlation coefficient means that the slope in your equation also has to be positive. Okay, so let's try another example in your packet. Now, we're not going to have time to do all of them, so we're going to skip number 2, and let me zoom in a little bit here. Let's take a look at number 3. Okay, so it says, the availability of leaded gasoline in New York State is decreasing as shown in the accompanying table. So we could see that our independent variable here is the year. Okay, and again, the independent variable, we're going to call that's going to be our X value. And the dependent variable is gallons available in thousands. So the dependent variable is our Y. And keep in mind, in this question, when they say in thousands, that means 150,000, 124,000. So keep that in mind. Okay, so part A, determine a linear relationship for X in years versus Y, gallons available, based on the data given. The data should be entered using the year and gallons available in thousands, such as 1996, 150. Okay, well, we're going to do this the same way we did the last one to come up with the linear relationship or the line of best fit. They both mean the same thing. All right, so we're going to go in our calculator, we're going to go to stat. Again, you're going to hit number 1, you're going to edit it. Now, since we have lists in there from the last problem, we're going to have to clear them out. So you're going to go up to L1, and you're going to hit clear and then down. Please don't hit the delete button because it deletes out the list. All right, then you're going to go over to L2. You're going to go up to the top of that column, highlight it, and hit clear and then down. All right, once you do that, you're going to just plug this first row of numbers into L1. So there should be 5 numbers in L1. And then you're going to plug the second row of numbers into L2. So there should be 5 numbers there. And always double check your numbers. Make sure you plug the right numbers in, because if you don't, then you're going to wind up getting the wrong equation. Okay, so now in order to find the equation, let's go back to stat in our calculator. And this time you're going to have to go over along the top to calc. And we're again going to go down to choice 4, which says lin reg ax plus b. And I just want to point out, if you were to scroll down, there's another one that says lin reg a plus bx. That's not the one we're using. We're using choice 4, lin reg ax plus b. So on your calculator, this is what you should see. Same thing we saw before. Again, under X list it says L1, Y list L2, nothing under these two, and you could scroll down and hit calculate. If you have the other calculator that doesn't show all of this, it's just going to say lin reg ax plus b on your screen, and you could just hit enter. When you hit enter, this is now what you should see. So again, it's a linear equation, so it's y equals ax plus b, and we're going to take this a value and substitute it in right there, and we're going to take this b value and substitute it in right there. And if you notice, if you go back to read part A, it doesn't tell us what to round to because these numbers terminate. They, end in 0.2 or 0.6. All right, so our equation is going to be y equals, in place of the a, we're plugging in a negative 6.2. We can bring down the x. And in place of the b, we're plugging in 12,525.6. Although keep in mind, these numbers are representing in thousands. So there's our answer for part A. One thing I do want you to notice is we have a negative slope, so that means we're going to have a negative correlation coefficient. As the years advance, as we go up in years, the numbers of gallons of gasoline that's available goes down, so they have a negative correlation. Okay, part B says, if this relationship continues, determine the number of gallons of leaded gasoline available in New York State in the year 2015. So since they give us the year 2015, the year represents our x value. So we're going to replace this x with a 2015. So we'll have y equals negative 6.2. And in place of x, we'll have 2015 plus, and you can bring down the 12,525.6. My comma kind of looks like a decimal, so let's make that a little better. Okay, so you can really just plug this in your calculator and see what we're left with. Okay, so when I plug this in my calculator, I got 32.6. Now, it doesn't mean that there's 32.6 gallons. It means there's 32.6 thousands of gallons left. So you can either just stick the word thousands after that. So you can just, and let's write gallons, so we know it's gallons. Or if you just want to write it without the word thousands, you could just write that as 32,600 gallons. So either answer is fine. Okay, and then finally part C says, if this relationship continues, during what year will leaded gasoline first become unavailable in New York State? All right, well, if it's unavailable, that means there's none left. So since the Y represents the gallons available, we're going to have to replace this Y in our original equation with a 0. And then we'll just solve for X on this side of the equation. So we'll have 0 equals negative 6.2X plus 12,525.6. Okay, so to solve, we would first subtract this 12,525.6 from both sides. All right, so that leaves us with negative 12,525.6 being equal to negative 6.2x. And let's just divide both sides by negative 6.2. Okay, so when I plug this in my calculator, I get x to be equal to 2020 point, I'm just going to round here, 258. Okay, now we want to know during which year will this happen? Well, this happens within the year 2020, so that's going to be our answer. Okay, so it looks like on this page I did not know how to number the questions. It goes from 4 to 6. But what we'll do is we'll do number 4 together, and then I'm going to have you try number 6 on your own. All right, so number 4, let me just zoom in here. It says the number of newly reported crime cases in a county in New York State is shown in the accompanying table. Write the linear regression equation that represents this set of data. Let x equals 0 represent 1999. So this is really important. If we're going to be letting x equals 0 represent 1999, then when we go to plug these in our calculator, we're not going to plug in a 1999. We're going to be plugging in a 0. And if 1999 represents 0, then 1 year later, 2000 would represent 1. 2001 would represent 2, and 2002 would represent 3. So be really careful when you plug these in your calculator to use those numbers. Okay, so let's go to Stat in our calculator. We're going to hit Enter on choice 1, which is Edit. And again, we're going to clear out the lists that are in there. So you're going to go up to L1 and highlight it and hit Clear and down. Remember, never hit Delete. You want to hit Clear. Then you're going to go up to highlight L2 and also hit Clear and down. So in your first column in L1, you're plugging in 0, 1, 2, 3. Remember, don't plug in these numbers. I think what's going to happen if you do is when you go to make a linear regression, your calculator is going to say like overflow or something. All right, and then under L2, you're going to plug in these y values. Okay, so the independent values go in L1, and the dependent values go in Y2. All right, so when you finish doing that, you're going to go back to Stat, same thing over and over again for each of these, over to Calc, and down to choice 4, which says linreg AX plus B. Okay, then once your X list says L1, your Y list says L2, you're going to scroll down to calculate and hit enter. And when you do, this is what you should see on your screen. Okay, so it just says write the linear regression equation. It doesn't tell us to round because, again, we have terminating decimals, so that's nice and easy. Just take this and plug it in for A, and take this value and plug it in for B. All right, so our linear regression equation winds up being y equals negative 35.5 x plus 457.5. So let's circle that because that's the answer to the first part of the question. Even though they don't break this up into an A and a B, there really is a part B. There's a second thing they want us to find. It says, using this equation, find the projected number of new cases for 2009 rounded to the nearest whole number. Okay, well, if 1999 represents 0, then 2009, 10 years later, would represent the number 10. So what we can do is we can take the x and replace it with a 10. So we'll do that over here. Y equals negative 35.5 times 10 plus 457.5. Okay, so when you plug this into your calculator, you get y equals 102.5. But the question says to round to the nearest whole number, which makes sense because if you're talking about number of crime cases, you can't have a decimal of a case. So 102.5 rounds up to 103. So we have 103 new cases in the year 2009. And again, I want to just point out that because the slope of our line is negative here, the correlation coefficient, look, you can see right here in the calculator, is also negative. Which does make sense because as the years are going up, the number of new cases is going down. Okay, so what I'd like you to do now is I'd like you to try number 6 on your own, so you can pause this, and then we will go over the answers after you're done. Then you can start up this video again. Okay, so as you can see, the answers for number 6 are right here. The linear equation, you can see in part A is this, and here's what you should see on your calculator when you did it. Make sure you round to 5 decimal places. In part B, you had to plug in 610 for the x, because x is the number of theaters. And you could just plug that all in your calculator to get $4.56 million. Then for part C, they wanted to know the minimum number of theaters that would generate at least $7.65 million. So you can plug in 7.65 for the y, for the earnings. And just solve. When you solve, you do get 912.6, I rounded 6229, but you do have to round up because you would need, we want to generate at least $7.65 million, so we would need 913 theaters to do that.